Imagine replacing our sun with something so massive that its outer edge would swallow every planet in our solar system, not once, but more than 40 times over. Light itself, moving at the fastest speed anything is allowed to travel, would need roughly 2 weeks just to cross from one side of it to the other. That object exists. It is real, it has been measured, and it currently holds the title of the most massive black hole ever confirmed. It is called TON 618, and it sits at the center of a quasar roughly 10.8 billion light-years away, in the direction of the constellation Canes Venatici. It was first spotted in 1957 in a routine survey of faint blue objects, decades before astronomers even understood what a quasar was. Nobody realized what they had actually photographed. Here is the scale we are actually talking about. Depending on which measurement method astronomers trust, estimates place the mass of TON 618 somewhere between roughly 40 billion and 66 billion times the mass of our Sun. Even at the lower end of that range, this is a single object outweighing hundreds of billions of stars combined. At the higher estimate, it is more massive than every single star in our entire Milky Way galaxy put together. Its event horizon, the boundary beyond which nothing, not even light, can escape, stretches across roughly 1,300 astronomical units, more than 40 times the distance between our Sun and Neptune. And it is not just massive, it is blinding. TON 618 shines with the brightness of roughly 140 trillion suns, making it one of the most luminous single objects ever observed anywhere in the universe. That brightness is so extreme that it completely drowns out the light of its own host galaxy. Astronomers cannot actually see the galaxies surrounding TON 618 at all. What they can detect is an enormous cloud of glowing hydrogen gas, called a Lyman alpha blob, spanning roughly 330,000 light-years, more than twice the width of our entire Milky Way, radiating outward from a galaxy so thoroughly outshone it remains completely hidden behind its own black hole's glare. Now, to be honest about the uncertainty here, because good science requires it. The exact mass of TON 618 has been debated for years, and the two competing estimates, 66 billion and roughly 41 billion solar masses, come from analyzing different spectral lines in the quasar's light, each with its own strengths and limitations. And TON 618's crown is not entirely uncontested either. In 2025, a separate study using gravitational lensing, a completely different measurement technique, identified another black hole weighing in at roughly 36 billion solar masses inside a system called the cosmic horseshoe. Lensing measurements are considered especially reliable, which makes that result genuinely significant, even though it still falls short of TON 618's own estimates. But the real mystery here is not just how big TON 618 is, it is how it ever got that big in the first place. Physicists have calculated a theoretical ceiling on how massive a black hole can become through ordinary accretion, the steady process of pulling in surrounding gas and dust over time. Beyond a certain mass, radiation pressure from the black hole's own feeding process should push infalling material away faster than gravity can pull it back in, effectively capping its growth at somewhere around 50 billion solar masses for a non-spinning black hole, or higher still if the black hole is spinning rapidly. TON 618 sits right at, or by some estimates beyond, that theoretical limit. And it reached that size when the universe itself was only around 3 billion years old, a small fraction of its current age. Under standard models of how supermassive black holes grow, there should not have been enough time for an object like this to form through normal feeding alone. That places TON 618 in the same puzzling category we have looked at before on this channel. An object whose sheer existence suggests our understanding of early black hole growth is still missing something fundamental. Whether that means multiple black holes merging together far more often than expected, an unusually efficient feeding process in the early universe, or some other mechanism nobody has fully identified yet. What remains completely certain is the scale of what we are looking at. An object so overwhelmingly massive and so unbelievably bright that it hides an entire galaxy behind its own light, sitting nearly 11 billion light-years away, quietly testing the outer limits of what physics currently says should even be possible. What do you think? Is TON 618 close to the true upper limit of how big a black hole can get? Or is something even larger still waiting to be found? Let me know in the comments. Subscribe, Because next time we are covering OJ287, a pair of supermassive black holes locked in orbit around each other, one repeatedly punching straight through the other's disk of gas on a schedule so precise astronomers can predict it down to the week.